So, can the most abstract math really make the world a better place? I mean, it sounds a little out there, right? We're talking about pure mathematics. Can it really have a tangible, positive impact on our actual world?
Yeah, I mean, can this super theoretical purist of the pure math really roll up its sleeves and help us solve messy, real-world problems like climate change? It totally sounds like a long shot, I know, but stick with me, because that's exactly what we're going to dig into. And look, this right here, this is the heart of the problem. Our world isn't some neat little system you can just plug into a simple equation. No way. It's this dizzyingly complex, tangled web of, well, everything. Organisms, ecosystems, industry, all interacting. It's just mind-bogglingly complex.
So, this is where our story really kicks off. Enter John Baez, a mathematical physicist. Back in 2011, he's looking at the state of the planet, and he's worried. He basically puts out a call for something he calls green math, a new kind of mathematics that could actually deal with all this earthy, messy, real-world complexity. And yeah, he had a very specific tool he wanted to use.
And that tool? It's called category theory. Okay, I know. It sounds super intimidating, right? But seriously, stick with me on this one, because the main idea behind it is actually surprisingly simple. So what on earth is it? All right, here's the big idea in a nutshell. Category theory doesn't really care about the things themselves. Instead, it's obsessed with the relationships between them. It's not about the what, it's all about the how. How things connect, what they do. It's a math of connections, of processes. And this is such a perfect way to think about it. Take a chess king. What makes it the king? It's not the wood it's carved from, right? No, it's the moves it's allowed to make. It's the rules that define its relationship to all the other pieces. You could literally use a salt shaker instead. And as long as you move it like a king, for all intents and purposes, it is the king. The identity isn't the object, it's the relationships.
And you know what's crazy? We do this kind of thinking all the time and don't even realize it. Think about it. You know you can add $5 and $3 to get $8. Make sense? You can multiply 5 feet by 3 feet to get 15 square feet. Cool. But what about $5 times $3? Is that 15 square dollars? Of course not. That's meaningless. And we just know that. That's because dollars and feet are in different categories with different rules. And trying to mix them up like that, that's called a category error.
Okay, so that's the theory. It's a neat idea. But the billion-dollar question is, does it actually work? Like in the real world? Let's take a look. So while it's not solving climate change yet, applied category theory has had some really big wins in a couple of other key areas. Epidemiology, modeling how diseases spread, and get this, AI safety. Okay, so take pandemics. Epidemiologists draw these diagrams with boxes or stocks of people, susceptible, infected, recovered, and so on. And then you have arrows or flows showing how people move between those boxes. Well, a category theorist looks at that and goes, aha, that's our language. The boxes are the objects, and the arrows are the relationships, or morphisms if you want to get fancy. This whole framework lets them stitch different models together with a level of mathematical certainty they just didn't have before. And the AI safety thing is just, it's so clever. I mean, how do you let an AI run something super critical, like a power grid, without being terrified it'll mess up? Well, using category theory, you can build a perfect mathematical model, like a digital twin, that has the exact same logical structure as the real thing. It behaves the same way. So the AI can practice on this digital sandbox, make its mistakes there, and learn, all before it ever gets the keys to the real-world system. It's a game changer for building trust. But look, as cool as all that sounds, it's not all sunshine and roses. This whole field is facing some pretty big challenges and a lot of skepticism. Which, brings us right back to where we started. If this stuff is so perfect for complex systems, why isn't it being used for climate change? That was the whole point of green math in the first place, right? And here's the reality check. The climate models we already have, they're incredibly sophisticated. They work pretty well. So you can imagine trying to convince an entire field of brilliant scientists to just throw out decades of work and start from scratch with this weird new abstract math. That is a huge ask. It's a massive investment of time and people for a payoff that isn't totally guaranteed. Yeah, and this quote from Matteo Cappucci, one of the people in this field, it just nails the feeling. He says, when I say we're underdogs and nobody likes us, it's not completely true, but it's a bit true. You can just feel that struggle, right? They feel like they've got this amazing new tool, but convincing everyone else is a real uphill battle. But maybe we're focusing on the wrong thing. Maybe the real power of this math isn't just about building better computer models.
Maybe it's about something way deeper, a whole new way of seeing the world itself.
And this is the big idea that John Baez has been building towards. What if our biggest problem isn't that our models are bad? What if it's not about data or processing power? What if the real problem is that we fundamentally misunderstood the world, that we've put it in the wrong category?
Think about how we've seen the world for centuries. We see it like a machine. It's built to do a job. It takes stuff in, it spits stuff out, and it creates waste. But that's not what an ecosystem is. An ecosystem is this living, evolved, interconnected web. There is no waste in an ecosystem. One creature's waste is another creature's food. They're two completely different ways of being, two totally different categories.
And this is where it all comes together. This is Baez's real hope. It's not about getting a more accurate temperature prediction. It's the idea that if we can create the language, the math, to see the world for what it is, as a deeply interconnected whole, and not just some machine we can use, maybe, just maybe, that understanding will help us be a little kinder to it.
So, where does that leave us? After all this, what's the verdict? Can this super abstract math really make the world a better place?
Let's be real. It's not a magic bullet. It's not going to swoop in and solve climate change or fix all our problems overnight. That's just not how it works.
But honestly, that's kind of missing the point. Its true power is that it's a new lens to look through, a whole new language. It gives us a solid mathematical way to describe and really get our heads around the interconnectedness of everything, from a virus to a forest to the entire global economy.
And that leaves us with one last big, provocative question. What if we've been treating the world like a machine when it's really a living ecosystem? What if the biggest, ugliest problems we face are simply the result of one giant category error?